Welcome back, developers. Today, we are leveling up our AI architecture. We are moving beyond single prompts to master the orchestration of sequential, transformation, and router chains. Let's get started. To kick things off, let's understand why we need advanced chain architectures. A standard LLM call is fantastic for a quick summary or translation. However, when we hit real-world enterprise requirements, a single call falls short. If you ask a single prompt to query a database, format the result, and explain it, the model gets overwhelmed. The solution is architectural orchestration using chains. Today, we are focusing on three foundational patterns: sequential chains that run in a fixed, predictable order, transformation chains that modify data mid-flight, and router chains where the LLM itself dynamically decides the next step based on the input. Look at the diagram. On the top, we see the traditional single-call approach. It's a simple, closed loop. On the bottom, we see the advanced chain approach. The data moves through discrete steps, hitting decision nodes or transformation functions before finally reaching the end. This modularity is what gives our applications reliability and scale. Let's dive into sequential chains. This is the next level up from a single call. A sequential chain is a deterministic workflow, meaning the steps are fixed and known ahead of time. Think of it like a factory assembly line. For instance, in a text-to-SQL application, you have two distinct LLM calls in sequence. The first generates the SQL query from natural language, and the second takes that generated query and writes a human-readable explanation. By breaking this into a sequence rather than one massive prompt, we drastically increase the accuracy of both steps. You use the pipe operator to link these steps together, ensuring the output of the first is seamlessly mapped to the input of the second. This sequence diagram illustrates a perfect sequential chain. The user submits a natural language request. Chain 1 receives it, interfaces with the LLM, and outputs a raw SQL query. Instead of returning to the user, that SQL output is immediately passed to Chain 2. Chain 2 processes it and returns the final, polished explanation to the user. The flow is strictly linear. Next, we have transformation chains. In the real world, data is messy. You rarely pass the raw output of one LLM directly into another without needing some kind of adjustment. This is where transformation comes in. A transformation step allows you to inject pure Python logic directly into your declarative pipeline. Why is this critical? Because maybe you need to strip out hidden HTML tags, filter a list, or lowercase a string before the next LLM step sees it to prevent errors. We achieve this by wrapping a standard Python function in a runnable lambda. Once wrapped, this custom transformation behaves exactly like any other LangChain component, allowing you to seamlessly pipe data through it mid-flight. Here we see the crucial role of a transformation node. The raw LLM output on the left might contain markdown backticks or extra white space that would break a downstream database query. It passes through our runnable lambda transformation step, which sanitizes the data. Only the clean, validated string is passed to the next LLM chain on the right. Now we reach the most powerful pattern, router chains. Unlike a sequential chain where the path is fixed, a router architecture hands the steering wheel to the LLM. The LLM acts as a triage agent, deciding dynamically which predefined step should be executed next based on the user's input. Imagine building a travel assistant. If a user asks about flight refunds, you shouldn't run that through your hotel booking logic. A router evaluates the intent of the query, e.g., travel info versus accommodation booking, and dispatches it exclusively to the specialized chain built for that exact task. This modularity reduces hallucinations because specialized chains only handle what they're experts at. This flowchart is the classic router pattern. The user query hits the router LLM in the center. The router acts as a switchboard. It doesn't answer the question. It merely extracts the intent. Based on that intent, it routes the execution to either the sales, support, or billing chain. Each downstream chain is highly specialized. Let's deep dive into how to build a router safely. The biggest risk with routers is that LLMs are conversational. If your routing logic expects the word billing, but the LLM outputs, "I think this belongs to the billing department," your application crashes. To fix this, we enforce strict constraints using structured outputs. We define a pedantic schema that explicitly restricts the LLM's choices, for example, using a literal type that only allows sales or support. By calling with structured output on the LLM, we guarantee that the model will return a clean, parsable JSON object containing only our exact routing key. This transforms a flaky, text-based guess into a robust programmatic switch. Look at this simple class structure. We define a route query schema that mandates a destination from a literal list of choices. The LLM is bound to this schema using the with structured output method. This architectural constraint bridges the gap between natural language unpredictability and deterministic software engineering. Let's apply all three concepts to a highly critical real-world use case, an intelligent support triage system. Imagine an enterprise receiving thousands of customer tickets daily. First, the ticket hits our router chain. The router LLM determines if it's a billing issue or a technical bug. Let's say it's a billing issue. It routes to our billing pipeline. Immediately, a transformation chain takes over, using a Python function to extract the account ID and sanitize the text. Finally, this clean data enters a sequential chain specialized for billing. Step 1 safely queries the SQL database for the invoice, and Step 2 generates a polite refund email. By combining routers, transformers, and sequences, we've built a scalable, enterprise-grade resolution engine. This visualizes our support triage architecture. The new ticket enters the router. The router makes the critical split. On the billing path, the data passes through a transformation node to be cleaned, then sequentially queries the database, and finally drafts the email. All three chain architectures working in perfect harmony. As we conclude, the key takeaway is that true AI architecture is about modularity. You should avoid building a single God agent that tries to do everything. Instead, use routers to direct traffic to specialized sequential chains, and use transformation operations to ensure the data flowing between them is clean and formatted. By mastering these three architectural patterns, you elevate your applications from simple chat wrappers into robust, reliable, and scalable enterprise systems. Thank you so much for joining this deep dive. Please be sure to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram summarizes today's lesson. Advanced AI architecture relies on these three pillars: sequential chains for predictability, transformation for clean data, and routers for dynamic logic. Together, they converge to deliver true enterprise reliability. Thanks again, and keep building.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.